Hi everyone, it's Mr. Strickland again. I'm a little later doing these videos than I told you I would be. I made the first one and it was about 30 minutes long, and that's too long for you guys to want to listen to me. So I'm backing up and doing it again. I'm going to give you this vector tutorial in a couple of pieces. So bear with me, and I'm sorry it's Sunday night and it's a little bit late, but at least you'll have this for tomorrow. Let's jump right in with what you guys need to be doing. If we start with simple vector addition, you look at this problem. What's the magnitude and direction of the resultant of the vectors that are shown below? Well, if we do what we did in the second module, we just simply need to draw the resultant vector here. Green's a good color. Come across. There's the resultant, and let's see what the magnitude of this resultant will be. If we label these, if this is A and B and C, then we can use the Pythagorean theorem, and remember that A squared plus B squared equals C squared. Or if we rearrange this, let's say that C is going to equal the square root of A squared plus B squared. So C equals the square root. Let's see, 7 times 7 is 49, and 11 times 11 is 121. So C is going to equal the square root of, and I'm not good enough to do that in my head, so let me grab a calculator here. Math tools, calculator, there we go. Alright, so let's see, 49 plus 121 equal, if I take the square root of that, C is, well, C is going to be equal to, so I went ahead and got the square root, let's do it this way. C is equal to 13.03 whatevers. I didn't specify what these vectors represented, so it could be a velocity, it could be a displacement, or any of those types of things. So let's see, this hypotenuse is 13.03 units of whatever they are. Now, we need to find the direction of the resultant vector here also. So let me make a little room. Now, 13.03 is the tangent, and since this vector is pointing this way, we need to find this angle right here. And we can do that using these numbers that we already have here. So let's say that tangent theta is equal to opposite over adjacent. We put that in our notes the other day. So tangent theta is going to be equal to 11 divided by 7. Now I need to pull up a calculator that's got my identities on it. So tangent theta is going to be equal to, now since I'm trying to find actually the angle, I have to use this inverse tangent function. And so we just say 11 divided by, it was 7 I think, was it? 11 divided by 7 equal to 57.52 degrees. So tangent theta is equal to 57.52 degrees. Alright, that wasn't too bad, was it? Alright, let's go to the next one here. Now this is very much like what we just did. We just have to rearrange things a little bit. Let me scoot this over here. And I'm going to whip this out. Let's see. Remember that you can move these vectors around. That where they are doesn't really make any difference with how they add up. We can move them around all we want to, and they still add up the same. So if we look at things like this, then here we go. This is not so bad. 13 plus 4 over here. This makes this vector on this side a total of 17, and negative 12 plus 3. If we add those together, our resultant over here will be negative 9. And then when we want to add all this together, I may have used my terms incorrectly there. The resultant and will be this vector across here. Excuse me. And we can calculate this the same way we did just a moment ago. So we can, if we call this you know, A and B and C, then C is going to equal the square root of 17 squared plus negative 9 squared. So C will be equal to the square root. Let me get my calculator back out. Math tools, calculator. There we go. 17 squared, 289, plus 9 times 9 is 81. So C is going to equal, let's see, let's add this up, 289 plus 81 equals, take the square root, so C is equal to 19.23 whatevers that we have here. 19.23. Great, now we have to find the direction. So let me clear some space where we can operate here a little bit. And we'll tackle the direction. Now, since we're looking at the direction of this vector, we need to find this angle here. And we can use the tangent function again if we want to. So tangent theta is equal to opposite over adjacent. So tangent theta is equal to what? Now, when we're looking for the opposite side, we're talking about the side that's opposite to that angle. So in this case, it was 9. Now, we're not going to use negative 9 because we're simply looking at a ratio here. So tangent theta is equal to 9 divided by 17. Now, this is a little different. Well, no, it's not. It's the same as what we just did. Since this is my second video, I'm getting lost myself here. 9 divided by 17 is what we need to do. So I'm looking for the inverse tangent of 9 divided by 17. And let's see what we get there. 27.89 degrees. Tangent theta is 27.89 degrees. So now we've got the magnitude was 19.23 and the angle was 27.89 degrees. Now, one of the things I'll mention here, and when you look at your homework, usually when you have these triangles, you look for that interior angle. Now, when you did your modules, if you recall, they did the angles this way. And so if you were working on one of your modules, then look what you'd have. You'd have an angle of 270 degrees because that's 3 times 90 plus 27.89 degrees. That would be actually the angle in space, like if this was an aircraft or something that was moving through space. This would be the answer you'd have. But for most of the problems that you're going to be solving on your homework or when we take the test, if you're solving for this interior angle of the triangle, you'll just stick with this one that we have circled here. I just wanted to mention this bottom part down here so you wouldn't think I was crazy. This does match up with what we did on the modules, but yeah, there you go. All right, let's look and see if we can do one more very quickly. All right, find the components of the vector below. Now on this one, 15 is the hypotenuse, and we're going to be looking for a magnitude of in the y direction and a magnitude in the x direction. And so if you remember what we took in our notes the other day, to find the y component here, we can take 15, which is the magnitude of the hypotenuse, and multiply that times sine theta to get y. So y is going to be equal to 15 times the sine of 20 degrees. So y equals 15 sine 20. Let's pull our calculator up here. So 15 times sine 20 degrees equals 5.13. So the y component is 5.13 units of whatever they are. The x component here will be 15 times cosine theta. So x will be 15 times cosine 20 degrees. So x will be equal to 15 cosine 20. All right, 15 times cosine 20 degrees will give us 14.09. So x equals 14.09 units. So there's your x component, and there's your y component. And I guess we're near the end. I'm going to stop this video at this point. One caution that I might give you while you're using your calculator, if your numbers are looking really strange, make sure that your calculator is set to work in degrees and not radians, because if you're set to radians, that can cause you all sorts of problems. But I'm going to stop here, because the next problems that we're going to do, we're going to move over here and find one where we've got to do a little extra, and then we're going to do a couple of story problems. But let's leave this. This will be video tutorial 1, and then I'll come back in a moment and I'll make you a second one.